Hey there, can everybody hear me? Cool, thumbs up, sweet. Okay, so yeah, my name's Alex Steven. I'm a software engineer at Google. I go by @RambleRaptor all across the internet. And today I'm going to talk about Chef and Google Kubernetes Engine. So quick little overview of what I'm going to be talking about today. I'm going to talk about first, what is Kubernetes? Why is Kubernetes cool? Why is this something that you might be interested in running your production workloads on? Then I'm going to talk a little bit about Google Kubernetes Engine. Subtitle that is like why you don't ever want to run your own Kubernetes cluster. Let somebody else deal with it. Going back to kind of the notion of where does Chef fit in with all this, and what is cloud native? It's like one of those buzzwords that we hear about all the time and has a very nebulous meaning. And then finally, I'm going to do a little demo where I'm going to show Chef and Kubernetes together. So just kind of to start out with, get a feel for the room, how many of you have heard of Kubernetes? OK, so for people watching at home, that was every hand in the room. How many of you have played around with Kubernetes a little bit? OK, so a couple less. And then how many of you are actually running Kubernetes in production? OK, so that's maybe 10, a little more than a handful. OK, cool. So just to kind of get everybody on the same page, like what is Kubernetes? The big thing that I think about is that Kubernetes is a platform for containers. It's an abstraction away from all the infrastructure. The idea is you have some containers. You throw them onto Kubernetes. Kubernetes figures out where on your infrastructure it's going to run. And then everything is a container. And the cool thing about that is your containers, you can run them anywhere. You can run them on Kubernetes. You can run them on your production Kubernetes cluster. You can run them on your staging Kubernetes cluster. You can run them on your dev environment. And because of that, you can get a really good sense that as you work through your pipeline from development to production, that everything is going to work correctly. There's not going to be any weird edge cases where production works differently than staging, works different than the dev environment. And just quick little bit of history fun fact. Google's been doing the whole containers and platforms and let's run containers everywhere for like 10 years. Google was pretty much built on the idea of running containers on a platform. So this is kind of what, if you look at like a bare metal, this is what your Kubernetes cluster is going to look like. And I don't really want to like stay on this slide for too long, because the idea is there's a lot of talks where you're going to be learning about how a Kubernetes cluster works and all of the different pieces that go into it. This is not going to be one of those talks. I'm not going to be talking about how the Kubernetes master works and leader choosing and consensus and all that. All you need to know is that you're going to have a bunch of workers. Those workers are going to run containers. And the number of workers you have kind of dictates the amount of compute power you have. If you have one worker, you have this much compute power. 3 workers, you have this much. And you can scale it up to a point where you have football fields full of server racks that have planet-sized computing, as Kubernetes loves to say. So because Kubernetes is a platform, and because everything is a container, you can mix and match things really easily. It's a platform. As long as you are deploying containers onto this platform, that's all you have to think about is your container. Kubernetes will make sure everything mixes and matches properly, and everything is segmented off from one another, so you don't have to worry about if I deploy one container and another container that they're going to interact in strange ways and cause me to have weird race conditions that are going to fail on my production services. Another great thing about Kubernetes, scale. If you need more scale, take a container, deploy 3 more of the exact same container. Now you have 4 times the scale. Likewise, if you have 4 containers and you see, oh, I'm not actually using that much compute power, I need to scale this back. Get rid of 3 of them. Go back down to 1 container. And Kubernetes actually has the great ability to auto-scale your clusters. So as it sees that CPU usage is going up, it can spin up. As CPU usage is going up on your containers, it can just spin up more containers for you, and then vice versa, I can get rid of them. This is kind of the last thing, and I think this is going to be one of the themes throughout this talk. What does cloud native mean? So like when I think people think about cloud native, they start getting this idea of, well, I'm going to be writing 12-factor apps and microservices, service-oriented architectures. I just have to take everything that I have and start it from scratch with this whole laundry list of new things. And in some cases, I guess that could be true. The big thing for me when I think about cloud native is everything is immutable. In an on-premise world, we're used to this idea of we have servers and racks, and if the servers don't work, we're not going to go down to the rack, rip out a server, smash it onto the ground, and go to Best Buy and buy a new one. Our bosses would be very angry at our credit card bills. So instead, in the cloud world, that's exactly what we're going to do. We can spin up new virtual machines. We can spin up new Kubernetes containers in the blink of an eye. We can do it through the command line. We can have automated tooling that does it all for us. So we don't have to ever really think about how are we going to tweak what we have right now? How are we going to fix it? We just need to make sure that when I deploy something for the first time, it works. And if it's not working, just get rid of it and build a new one. Because I know when I build a new one, it will be working when I start it off. And so this kind of means no more snowflakes, no more SSHing into machines. Prod looks like staging because prod and staging are running the exact same software, the exact same infrastructure, and none of these things are living long enough for them to deviate from one another. So that's Kubernetes. I think that's why Kubernetes is cool. It's a great platform. You get auto-scaling, you get immutable infrastructure. You just have to think about containers, and you don't really have to think about how the containers are running with each other, how they're interacting with each other. It's a great abstraction for physical infrastructure. So now, kind of as I showed a bit earlier, when I showed a full diagram of a Kubernetes installation, getting a Kubernetes cluster set up and actually making sure that everything is working properly is hard. And it's not necessarily a problem that any of us want to face. And so that's the great thing about Google Kubernetes Engine, is Google has a great solution for actually giving you a hosted Kubernetes cluster. And this is a regular, pure Kubernetes cluster. There is nothing special about it. You can use all of the Kubernetes tooling that you are used to. You can use all of the Kubernetes infrastructure and knowledge that you already have. If you are a developer, a Google Kubernetes Engine cluster is not going to look any different from an on-prem cluster or a hybrid cloud cluster or any other public cloud cluster. It's just going to look like a Kubernetes cluster. So I guess the next question is, well, if I can have Google host my Kubernetes cluster and it's not going to look any different than any other Kubernetes cluster, why should I care? Why should I let Google handle my Kubernetes infrastructure for me? And I'm just going to go through a couple of pretty quick reasons. One, we have the largest network in the world. We run it all on our own private fiber, more than 100 peering locations, pretty much. The only time that we will not be running, that your network connectivity from end to end will not be running on our fiber and our network is from the customer's house to their nearest point of presence. Everything else is going to be running on Google. We can auto-scale up to like 1 million queries a second with absolutely no pre-warming. The idea being that if you get hit with a distributed denial of service attack, Google's network is just supposed to yawn and move on. Another great thing, we're a pretty sound financial decision. You get committed use discounts, don't have to pay anything up front, no cancellation fees. If you're running normal virtual machines, you get some other fun things. Not much more to say there. Additionally, we have all the certifications. So if you're federal, financial, health, all the security things, you can check all of this out at cloud.google.com if any of these are applicable to you to kind of get more information. And then just kind of another cool fun fact that I'd like to bring up. Google built Kubernetes. Like Kubernetes is based on our internal infrastructure called Borg that we've been running for 10, 15 years, some crazy amount of time. And we actually developed Kubernetes originally using a lot of the same ideas and the same principles that we were using to run our internal infrastructure. And then we decided, well, wait a second, we really want this to succeed beyond Google. So we actually handed it off to the CNCF, Cloud Native Computing Foundation, so that they could help kind of build a community that Google could be involved with, but not necessarily controlling. We didn't want to be completely in charge of everything. We wanted a community to build up around it. So we're committed to watching the Kubernetes ecosystem build up and then providing great tooling and kind of hosted infrastructure so that you can use Kubernetes in the way that you and the community are best used to. So I kind of sped through a lot of that. I've been talking a lot about Kubernetes. The next big question is, well, how does Chef play into all of this? And also, like, in a world where I'm not running on-premise, what does cloud native look like? And like, how can I fit the world of on-premise Chef installations and make it look more like the cloud native immutable infrastructure world that we want to be building up towards? So just out of curiosity, how many people here have Chef cookbooks and use them to deploy applications to prod? OK, so that's pretty much everybody in the room. So I think one of the big ideas behind Chef is this idea of convergence. I've got this node. I run Chef client on it. I run a cookbook on it. And I'm converging this node so that it looks like what the cookbook says it should look like. And if I change my cookbooks, I run it again. And Chef kind of calculates a diff between what my cookbook looks like and what my on-prem infrastructure my on-prem node looks like. And then it calculates the diff and converges the node again. So now my node looks exactly like my cookbook. And we keep going through this iteration cycle over and over again. This doesn't really work, though, with immutable infrastructure. Immutable infrastructure means I build something and it never changes. But in Chef, I'm constantly, one after another, building and converging and changing my nodes. So how are we going to make this work? Convergence is such a big part of the Chef ecosystem that we're going to be converging something. It's a cornerstone of how we think about Chef. What is it that we're going to be converging? And I think we're going to be converging two separate things. One, we're going to be converging our infrastructure, so the actual infrastructure that we have running in the cloud. The great thing about the cloud is you can have whatever infrastructure you want, and you can radically change what that infrastructure looks like within a couple lines of code. You can do it very quickly. You don't have to go out and requisition new machines. You don't have to set them up in your data center, et cetera, et cetera. And so there's going to be a lot of flexibility. And potentially, depending on how our needs change over time, our infrastructure is going to change over time. And we need to be able to converge on that. The next thing is, how are we going to use our Chef cookbooks now? And instead of converging on nodes and constantly changing the nodes, I think the better way, the more cloud native way to do this, is to converge on images, converge on Docker images. So we create a Docker image, and then we converge on it. It's a one-time thing. And then after that, we go ahead and use that image throughout our Kubernetes cluster. I'm going to talk more about that in just a second. So converging infrastructure. This kind of an obvious thing to say. You can't be cloud native without actually being on the cloud. So how are we going to build up all of our cloud infrastructure? The big thing I think we want to do is we want to use all of the same Chef knowledge that we have already. There are a million different ways to spin up cloud infrastructure. There are command line interface tools. You can run bash scripts. You can use web UIs. There are tools like Terraform that are out there that allow you to write up what your cloud infrastructure looks like and then use that tooling to build it up and converge upon your infrastructure. We can also use Chef because everybody in this room said they're using Chef in production. Everybody in this room knows about Chef. So we can use that knowledge and use that infrastructure in order to converge upon this infrastructure. So We at Google, I've been building out for the past year a collection of cookbooks with this goal in mind. How can we converge our infrastructure the same way that we converge our nodes? Write up scripts, write up chef recipes that describe all of my infrastructure, all the infrastructure that I want to have, run these recipes, and then let chef do what it does best. So look at what the infrastructure is currently, look at what the infrastructure is in my recipe, the infrastructure that I want to have, and then go ahead, do the difference comparison, and converge upon the correct solution. So now my infrastructure looks like what I want it to look like according to my recipe. So we can do this for all kinds of cloud infrastructure right now. We can do it for the more traditional virtual machines, for DNS records, for SQL databases. We can also do this for Kubernetes clusters. So I can define what I want my Kubernetes cluster to look like in a chef recipe, and then I can tell chef, go converge on this. And chef will make sure that whatever Kubernetes cluster I have on Google Cloud actually looks like the Kubernetes cluster that I've defined in my chef recipe. So we've got all these cookbooks. If you check them out on Supermarket, that's the link there. If you search around for Google, Google Cloud Platform, some combination of those things on Supermarket, you'll see them really, really quickly. The other cool thing, and Chef literally just announced this, I think Monday, Tuesday, within the past couple days, is inspect support for GCP. So now we can get into a really harmonious cycle of using Chef to converge on my infrastructure and build out the infrastructure that I want, and then using inspect to check compliance on this infrastructure. Does my Kubernetes cluster look how I want it to? Do my DNS records look how I want it to? And then we can continue and get into a very fast development cycle of building out infrastructure with Chef, confirming the infrastructure with inspect, and so on and so on. So now this is, I think, one of the trickiest things to think about in a cloud-native world is this notion of immutable infrastructure. In a cloud world, we want to keep things as immutable as possible so we're not fiddling with them. If something crashes, if something breaks, spin it down, get rid of it, bring up a new one. So how are we going to handle convergence? How are we going to handle configuration management for using Chef in this cloud-native immutable world? And what's going to happen is we're going to create Docker images. We're going to create images that we can then use as the basis for our containers. And the big thing is we're only going to converge once per image. And I know this is a very scary thought because it's a very different thought. Every time we make a change to our Chef cookbooks, we build a Docker image that runs Chef. It talks to our Chef server, it runs our cookbook, and then it does all of the things that we would typically do. So now I have a Docker image that looks identical to my on-prem Chef node. At this point, we're done with Chef. We have this image. We are not going to be touching this image. We're just going to be using this image in order to create containers that look identical to this image. And now, obviously, later on, we're going to decide, well, wait a second. I need to change my cookbook. I have alterations that I need to make. I need to install new packages. I need to do more configuration. And so now we're going to create, version 2, version 1.1 of this image. We're going to create a brand new image. And in the creation of this brand new image, we're going to do the same thing. We're going to associate ourselves with the Chef server. Chef is going to run. And now we're going to have an image that looks exactly like an on-prem node if that on-prem node had run v2 of our cookbook. And then the great thing about Kubernetes is, because everything is a container, we can run rolling updates. So I've got all these containers running v1 images of my v1 cookbook, and I can slowly take away some of those v1 containers and replace them with v2 containers that are running v2 of my image with v2 of my Chef cookbook. And this sounds like a very scary thought, I know. Because I think everybody in this room is used to, well, I've got this on-prem node, and every time that I converge upon this node, if I change 2% of my recipe, I'm only changing 2% of my node. So the other 98% that I know for a fact works, I'm not altering it. It's staying exactly the same. The big thing to think about is that's actually completely true in this case too. If I have a container running my v1 image and my v1 cookbook, and I do a diff with my container running my v2 image that has my v2 cookbook, the diff is going to be that same 2%. I've only changed 2% of the things. However, I've actually spun down a container, so got rid of it altogether, and then spun up a v2 container. So I'm going from 100 to 0 to 100 again. The end result is the exact same. And the great thing is, because Chef lets you work so quickly and lets you make changes so quickly and put those into your infrastructure, these containers are going to be constantly changing. You're going to be constantly making new iterations, getting rid of old containers running old images, putting on new containers running new images. None of these containers are going to be running for a long enough period of time for them to become snowflakey. You're never going to be SSHing into a container. They're just not going to be living for long enough for that to be an issue. But the great thing is, because of rolling updates, you're never going to have any downtime. Yeah, and I think another thing to kind of point out is that we're going to be evolving from here. You have all of this institutional knowledge in Chef cookbooks. You want to be able to use this on Kubernetes. That's great. As we continue to go on over time and as you get more entrenched into the Kubernetes world, you might figure out, well, wait a second. Building these images using my Chef cookbooks isn't necessarily the best route or the route that I want to use for getting deeper into Kubernetes land. So I think it's important to remember that there is no right or wrong way, at least in my opinion, to run things on Kubernetes. And your opinions of what you want to do and how your production workloads are going to be run are really going to differ over time as you kind of entrench yourselves more into Kubernetes land. And so with that in mind, I've actually got a little demo that I'm going to show everybody. So let's see. All right, can everybody see my screen all right? Cool. So to start out with, I've got a little on-prem application that I built. This is an on-prem application. It's a little Python web server. But the important thing is I'm deploying it on-premise using a Chef cookbook, which hopefully is no different than the way a lot of you are using Chef to deploy your applications. So let me show you that little application. So this application shows pictures of famous chefs. I was told recently, I guess in his TV show, he isn't a chef. He just goes around and meets other chefs. So I guess I've got to give like a little journalistic retraction or something. And just as a quick sanity check, as part of this app, I do the terrible security practice of leaking out the host name. So if I go to the host name, we can see this is running on some box called on-prem 2. There's no fancy load balancing. It's just a simple machine with a web server on it. So now, and I lost my SSH connection because I've been talking through slides for a while. Going to give that a second to reconnect. And hopefully it does, or else I'm going to be going to videos in a second here. Cool. So if I go to, this is my cookbook right here. I've got, a recipe that puts in a Git repo, it installs Python, does all the standard things. And so this can be run anywhere. It's just, this is a very standard Chef cookbook. So let's talk about now putting this into Kubernetes. And so what I first need to do is I need to build a Docker image. I need to build a Docker image that I'm going to base all of my containers for this application on. So I've got a little Docker file here. And it's maybe 10 lines long. Pulls down CentOS, exposes some ports. And then it runs a bootstrap script, which I'll explain in just a second. And then when I start up my container, it runs my Python app. Can everybody see my shell, by the way? Everything looking good on that? Yeah, sure thing. Text size. Is that looking better? Perfect. And then in my Bootstrap script, and it's a little lengthy just because all of this is going to be available on GitHub, and I wanted to make it easy for people to kind of use this script to build out their own workflows. I go ahead, I do some cert copying, I use the Omnibus Chef installer to install Chef client, I associate my Chef client with my Chef server, and then I run and I converge Chef using the same recipe I was using. So when I'm finished, my Docker image is going to look identical to how that on-prem node that I currently have right now running my on-prem application is going to look. Now, unfortunately, it takes a little bit of time for me to do that, and it's not really the most demo-friendly way for me to wait for 3 minutes as a bunch of things scroll by. So I've actually got right here the output of me building my Docker image. So you can see there's a lot of nonsense in here, but I pull down an image, so I've got a blank CentOS box. Let me start out the interesting part. So I run my Bootstrap script. Inside my Docker image, I am now installing Chef client, and then I am converging Chef. So now I'm starting at my Chef client, I'm talking to my server, and I'm running that same cookbook that I was running on premise. So I'm installing Python, I'm installing pip, I'm pulling down my Git repo, I'm getting all of the dependencies I need for my application, and now I'm done. So when I'm done, wrong prompt, when I'm done running this script, I have a Docker image that looks identical to that on-prem node that I showed you earlier. The big thing is, for the moment, I'm done with Chef. If I never touch my Chef on-prem cookbook again, I'm never going to build a new image ever again. So at this point, I'm going to push up this Docker image up to Google Container Registry. Google Container Registry is Google Cloud's version of a private Docker image repository. There's a bunch similar to them. The big thing is that you, sorry, I lost my train of thought there. The big thing is that it works great with Google Kubernetes Engine, so you get a bunch of really cool integration into the Google Kubernetes Engine web UI, which I'll show you in a second. So we're going to go ahead and tag this with a name corresponding to the place in Google Container Engine that I want to go. And need to actually spell this correctly. There we go. And then I'm going to go ahead and push that image that I just created that's currently sitting locally on my local machine up to Google Container Registry. And I kind of did this earlier. So the big thing to know is that conference Wi-Fi sucks, and it takes a long time to push that up. So I've now got this image, and I'm ready to deploy it onto a Kubernetes cluster. The first thing I need to do, though, is I actually need a Kubernetes cluster. So now we have to go back to this idea of converging on infrastructure. So I've got a little cookbook here. And inside this cookbook, I define some authorization things, and I'm defining this Kubernetes cluster that I want to build. In this Kubernetes cluster, we're going to have 3 workers. Each worker is going to have 500 gigabytes of disk space. The cool thing about these cookbooks that we've created is they have support for kubeconfig. So as part of this, these cookbooks are going to generate a config file that is going to be used by kubectl. Kubecontrol, I've heard it being called. I've always called it kubectl. So let's go ahead and let's run that. So we'll run chef client. And Chef is going to do its thing. It's going to grab all the dependencies. You're going to notice that happened really quickly. And that is because all of these cookbooks are idempotent. That is one of the really big ideas behind what we've built is if your infrastructure looks the exact same as what you're expecting your infrastructure should be, nothing should change. That's one of the cornerstones of Chef. If your node looks exactly like how your recipe defines it, nothing should change. Again, big concept of Kubernetes. So now I've got this great Kubernetes cluster. It's ready to go. I've got my config, which was auto-generated, already in place. So now I can use kube control to interact with my, I can use kube control to go ahead and interact with this Kubernetes cluster that I've built. So let's go ahead. I'm going to actually show you the Google Cloud console. And show you this cluster in action, show you that it's got no workloads on it. So this is the web UI. You'll see it again in a second. So you'll see if I look up my Kubernetes cluster, there's my cluster. And it doesn't have any workloads on it because I haven't put any workloads on it. So let's go ahead. Let's put a deployment on this. Let's take that Chef image that I had, that image containing my application that looks identical to my on-node application. Let's go ahead and put that on my Kubernetes cluster. So we're going to say kubectl run. We're going to call this Chef deployment. I'm going to use that image that I just created a second ago, version 1.0. And then each one of my containers serves up my application on port 5000. So I'll go ahead, also have that run on port 5000. And so you'll see, great, it's been created. I now have containers with this image running on my Kubernetes cluster. So the next big thing is we've got these containers. Let's expose them out to the world. So we'll go ahead and say kubectl expose the Chef deployment. We're going to use a load balancer type. So we're say put a load balancer in front of these containers I've created. Google Kubernetes Engine is awesome because load balancer is a native Kubernetes type. But Google Cloud knows if you want a load balancer, we'll put one of our Google Cloud load balancers with global availability and single IP and can handle 1 million queries per second. We'll put that in for you. And we're going to expose port 80 because that's where web traffic goes. And we're going to map that on my containers to port 5000. Cool. And then the last thing is DNS records. So obviously I want to point some kind of DNS entry to this. DNS records are infrastructure. We can converge upon them in the same way that we were converging upon our Kubernetes cluster a moment ago. So again, I've got a small little Chef script that's going to go ahead, C-R, that's going to go ahead and create our DNS entries so then I can access this. And so this little Chef recipe I wrote uses kubectl to grab the IP of the load balancer I just created and then associates it with DNS. So let's go ahead. I put it on a different DNS entry because DNS is terrible for, you never want to change DNS entries in a conference or ever. So again, we get to see our Chef, and I really wanted, there we go, that is the Chef I wanted to show up earlier. So this is cool. I've got something that looks the same as my on-premise node. The big question is, well now, at some point I'm going to change my Chef cookbook. What is that going to look like? So I'm going to go back to my image for a second, and in my Bootstrap script, instead of running the recipe docker2, now I want to run the recipe docker. I've made some alterations. I want to use a new recipe. And so I'm going to go through that same process that I went through earlier. I'm going to build a Docker image that Docker image is now going to be completely different from my old Docker image, but it's going to look like my node would look like if I ran Chef normally and had this new version of my cookbook. And I'm going to push it up to Google Container Registry. And so now if I pop over to Google Container Registry, where are you? Container Registry. If I look at my images, I've got two images. I've got my old image, version 1, which shows the application I was running on-prem. And then I've got version 1.1, which shows a slightly different application. It's the same app, but now the background's blue. And I had to make some Chef cookbook changes to this in order to deploy it. So now, how would I go about actually deploying this new version to the public? And again, Kubernetes has a whole bunch of different ways of interacting with it. So I'm actually going to use the web UI to show you how to do this. So I'm going to go to that deployment that I had that's running containers, and I'm going to do a rolling update. And I'm going to say, use the new version of my image, use version 1.1 instead. So if I had 3 pods running version 1, it's going to get rid of one of them. It's going to spin up a new container running version 2. Then it's going to get rid of one of the old ones and replace it with a new one. And then get rid of the last old one, replace it with the last new one. So when everything is all said and done, all my containers are going to be running the new version of my Chef cookbook. So let's go ahead. Let's go back to my app. We can see now the background is blue. And so every time that I make changes to my application, I'm going to go through the same process. I'm going to build a new image. I'm going to get rid of all of my containers running the old image. And I'm going to put on containers running the new image. So let me flip back to my slides. So now it's your turn to try this out. If you go to the supermarket, search for Google Cloud Platform or follow that link, you can get these Chef cookbooks for converging your infrastructure. And you can use this for both Kubernetes clusters, if that's something you're interested in, as well as all the other kinds of infrastructure you might use, DNS entries, SQL databases, virtual machines, firewall rules, et cetera, et cetera. If you're interested in learning more, cloud.google.com, you can learn more and get $300 in free credit. And I put on this slide that I'll be at the booth, but right now forklifts are taking my booth away to some shipping dock somewhere. So I will be here to answer questions. I'll be in the back or outside the room. And with that, thank you very much.